Hi everyone, welcome to ML Maven, where we share our machine learning journey to pick up some deep learning skills. I'm Johnny.
Hi, I'm Harriet.
So Harriet, so today this episode we're going to talk about what we learned this week in deep learning. We both have spent quite a bit of time learning new things, reading papers, and trying new um,
Methods.
methods and looking at different data sets. So Harriet, what did you learn this week?
Right, so this week something came up to me, and then I thought about trying to combine text data with tabular data. So the essence of combining text data with tabular data uh, is text data essentially is a sequential data. So for say,
So tabular data, like a spreadsheet, like a
right,
database,
exactly, yeah. So like any relational database, tables can
tables,
be
yeah,
represented as a
right.
tabular data, and then usually that means it's a snapshot of time for the data. So this is in statistics. People also call this cross-sectional data, but then text data, which is sequential. So usually in statistics, people call this time series type of data, or or longitudinal data. So basically, what I want to try this week is to combine these two format of data. So tabular data as represented as metadata to add on top of time series data or sequential data to hopefully can improve the accuracy of the prediction.
Right. So what did you? And you use Fast AI, right?
Right. Fast AI is almost like becoming a default of my first try for anything because it automate a lot of the steps for you already, which you only need to focus on the high level design of what you want to put your problem into. So then a lot of all those technical details have been handled for you. So that's why for tabular data, I use a Fast AI tabular module, and then for text data, I am using the Fast AI text module. And then what I find that how you combine these two modules is after you set up the two learners and then train them, and then what you only need to do is to get the embeddings for both tabular data and text data. Then you take out their classifier chunk for both of the modules, and then you combine the embeddings for the representation of tabular data as well as the representation of text data. So then you add together a whole one classifier chunk for these concatenated embeddings, and then go forward with the classification.
Oh, cool. That's very interesting. I'll be interested to see how you've actually uh, put the code together, and what were you trying to classify?
Oh, by the way, if you want to know more details, remember to subscribe our channel, and then we will keep you updated on that part. Sorry, what was your question?
What were we trying to classify? What was the text? The NLP data, and what was the tabular data?
Right. So I was trying on the IMDb data because that data has been tried by
The,
many different people, and
the
then
movie reviews. So the text would be the movie reviews.
right. So movie reviews, and then so the text, yeah, will be the movie reviews, and then the tabular data is something I try to extract more features from
Right.
those texts. So, for example, then it will include the length of the text.
Oh,
So
right.
it could be one feature, so which is one type of metadata that you can have from the text. And
Right.
another thing is Another one you can try is you can use the traditional feature engineering method. So for say like TF-IDF, so you can find out what are the most important keywords in either positive class or negative class, because this is a sentiment analysis problem. So therefore, these feature words can be also a metadata to represent the entity as a tabular data set.
Right. So it's just mainly metadata from the text itself, not
Right.
like the movie release year or other data that is other metadata that is related to the movie. But
You could possibly, if you can find those data, for sure it can be part of your tabular data. But if you only have the text data itself, like for sake, because some text you don't actually have those metadata, then these are the things that you can probably extract from the text itself.
right,
Yeah.
right. So with the tabular data, I guess you can. I guess the neural net can figure out whether, for example, like a longer review or shorter review might be mostly positive because people might just like to write shorter reviews if a movie is good. If they find it good, then they'll just write a couple of sentences. But if they're really angry or really unhappy with the movie, then they would write a longer review.
Exactly. Yeah. So these features are things that you find that can help to separate apart the two classes. Yeah.
Cool. Anything else?
Yeah, that's pretty much what I learned this week.
Cool.
How about you? I know you have tried a lot of new things this week,
Yeah,
and then got really exciting,
yeah,
right?
I've been
Things.
going a little
Yeah.
crazy with the optimizer. So uh, I'm sure a lot of people know there's this optimizer which is very common called Atom. So I found two papers this week, which is very recent. So one was released a couple of weeks ago, and one was released about a month ago, and they're both optimization to to Atom. So one is called. So the one that I want to share today is called Rectified Atom. And the most exciting thing about this paper is that it seems like that for uh, there's very little effort involved in trying to optimize your neural net by just you can pretty much just swap in. And I heard that people are getting better results um, in their algorithm. So I was pretty excited about that. So I immediately tried to do that with um, the Yelp review classifier that just to try to swap it in to see if I could get a better performance. But what I found out is that maybe so I also use Fastai, and I found out that um, it's actually Fastai is actually pretty good with what Jeremy did with URL fit. Uh, he's already achieving like something like crazy like 97%, 97.8 in the ULM fit paper. So I was trying to beat that, and I wasn't able to beat that at all. I could like only go up to like low 70, 97, 0.2 or something like
So
that.
guess kudos to Jeremy.
Yeah. Yeah, so it's really hard to beat, but I don't know. I've just been constantly been hearing from other people, other students of FastAI, getting better results uh, without doing any modification. So, uh, but I think they're doing CNNs any related to image classifiers. So maybe there's something different there. And also, I was trying to just with the Yelp data, I'm just fine tuning a language, just fine tuning the classifier. So maybe it's not as impactful with fine tuning a model.
So Jeremy, in case you find this video, if you have any suggestions, can you comment below?
Yeah, and then I tried the other apart from that, I tried implementing BERT, integrating that with um, uh, FastAI. So I found this really I found this Kaggle kernel online, and I pretty much just try to use all the code in that kernel, replace it with my data set, which is the IMDb one, to try to see if I can beat Jeremy's result in the course notes. So yeah, but what I found out, the interesting thing is that as soon as I put that in, I found out that just the BERT model is just huge, just by freezing the last layer, um, or no, freezing the whole model except for the last layer. There were still over 100 million parameters to be fine-tuned, so that's like a pretty huge model. So
that's not even to fine-tune the language.
Yeah, that's not even
right?
fine-tuned.
Yeah.
I'm not even doing that because
Yeah.
I might. Yeah, I don't know. I might have to spend like a couple of days just trying to fine-tune that.
And so probably AWS will send you like a
Crazy
$100
bill. Yeah,
next month.
yeah, it'd probably be like thousands of dollars just to fine-tune that. Well, maybe not. Maybe just like hundreds of dollars just to fine-tune that. Yeah, so those are the couple of things that I tried. So I wasn't able to beat any of Jeremy's record, but I'll continue to try.
And then we will give you an update, Jeremy. Yeah.
Yeah.
So there are two errors that you overcome for fine tuning BERT, right?
Yeah, so mainly it's just it's just mainly just trying to figure out which loss function to use. I noticed that in FastAI they come up with their they come up with a convenient flattened version of the loss of the cross entropy loss function. So so just by replacing and I believe that's what's being used if you try to create a language classifier, a text classifier model. Yeah.
So what is the difference between the flattened one and the non-flattened one?
Actually, I don't know. I just replaced it and it just works. So I'll probably have to go in and have a look because I just was testing that just before when we were recording this video. So yeah, because I was getting an error when I was running the model for BERT, and
mainly comes from the loss function definition, right?
Yes,
the
definition inside of FastAI.
Yeah, and then it's maybe because different loss function, the output is different. So some loss function has a raw probability output, but some loss function already has a softmax layer activation to output the binary output. So if that is different, then that may affect the downstream problem.
Yeah, and it's also the first time I tried to use a learner constructor, the learner class to just instantiating a plain learner class because I have to integrate with BERT. Because normally you don't really have to. I mean, there are a lot of convenience function in FastAI. There's a text language model learner, I believe, and then which is for language model training or fine tuning, and then there's the text classification. Learning, which is behind the scenes there's an RNN being instantiated. So and all the loss function is all the decision which loss function to pick, all that stuff is kind of abstracted away. So as a FastAI student, I think it's good to go like one level deeper. To understand the behind the scenes, what's actually happening. So that you can understand exactly what the framework is doing.
Yeah, exactly. Speaking of that, I actually also took a look at the text classifier function this week. So I found that because I was trying to find that there are different functions just to build the text classifier pipeline, and then I find that so firstly it was to what the first function is to actually try to concatenate the encoder part. And then the decoder part, and then the last function call of get text classifier is actually taking that part, but then resetting, so rebuilding the whole encoder decoder part, and then so I went on to take a look at the source code for get text classifier. So it uses reset function. So then I went to ask about it online about what does the reset function in get text classifier do, because that's basically the whole rebuilding part. At first I thought the reset function is to reset the weights of different layers, but someone told me later that no, it's actually not resetting the weights, but instead it's actually to reset the hidden state of every layer, every children of the model chunk. So that's what inside the scene, what is this abstraction function does. Yeah.
Cool. Yeah. So I think we've learned quite a lot this week, and we'll continue to dig deeper into fast AI and different data sets and different look at different papers to see if we can get better results and get it better performance. To continue to follow us, please subscribe and like the video, and we'll provide the links to the resources that we talked about. For example, the R-atom rectified atom paper. And also
Our child code.
and also our code, our Jupyter Notebook code. Thanks for watching.
Yep, so your subscription will motivate us to output more stuff for you.
All right, see you next time.
Bye.
Bye.